You typed now, you in comment. I
Yeah,
saw,
yeah.
I saw something written there. Good. So, what was I saying about assembly, right? So, assembly workbench is to check all the tolerances, clearances, and whatever constraints is there. All those things to verify it. Sometimes what happens is you'll create a part. Okay, then the 1 mm or 2 3 mm will be projecting outside when you assemble it. So, all those things corrections can be done in assembly workbench. Okay, understood. And one more thing about assembly is, see,
Yeah.
once your parts is once the parts is done, the your team, uh, the company manufacturing team, they have to assemble it. So they should know exactly how to assemble it. For that reason,
Mm-hmm.
also assembly workbench is used for drafting purposes. In drafting, they will show how to assemble it. What are the procedures how, in which they have to assemble the parts. Okay, even
Mm-hmm.
a note you will give. Okay, this thing comes first, this thing comes next, like that. You give a note also in that drafting. Okay,
Okay.
so these are the main purposes. Chumma chumma, if you put something there and here means it's not like the interviewer, right? Even those people will say, okay, they don't have the clarity of thought, karke they'll say. So it's better you
Mm-hmm.
use the mechanical terminologies mainly wherever you get now. You take some mechanical books, just write down some big words in some paper and just when you whatever you're saying, just add few words in between. That's all. Okay, they'll be like, oh, spot out. Oh, this person is so knowledgeable. He's more intelligent than me. Like that, they'll think. Okay, so
Okay.
you should
Mm-hmm.
psychologically try make moves.
Mm-hmm.
Now we'll go to this assembly workbench. So mechanical design. So assembly design is over here, right under part design. Just click this. So every single time you open Catia, right, you'll be introduced to this page, product workbench. Okay, every single
Mm-hmm.
time.
Mm-hmm.
I'll open new part. Okay, this is part workbench. So over here, I'll create some parts. So there are two different types of assembly. One is top-down assembly and other one is,
Bottom up.
yeah, bottom-up assembly. So what happens in top-down assembly? Google.
Mm-hmm.
So we'll just create some holes. So this is 50 mm. Just update it. Okay. So I'll just save this file. Save as. Here, most of the time when you're doing now, just give chamfer at the ends. Okay, because sharp edges it'll tend to hurt somebody. Okay, and don't give chamfer at these edges because machining is very difficult at these edges. Okay, again DFMA. Understood? Here, it's safety point of view. Like when somebody is handling or something, if the sharp edges are there, it's going to hurt them. So for that reason, we'll give a chamfer. And one more reason is when it's very sharp, it tends to crack at these edges. For that reason, we give chamfer.
Mhm.
Okay, at this locations. But somebody will come
Okay.
and ask you, "Oh, Prabha, give chamfer here also. It look nice." That time you should say no. I won't give that because there'll be a cost escalation.
Mhm.
Here it's like material is removing like this, automatically they'll remove like that. It's much more easy for the machining person also. But when you're going to give chamfer over here, angle is 45 degrees, so they have to make one more fixture to place it at one angle. Then they have to after placing it, they have to lock it in place. Here some scratches will happen. After that they have to remove this. Then again next side again setting time so much will take. Then this side also setting time so much will take. It'll take some 3 hours for just doing the chamfer. Within that time this whole part will be completed. Okay, so that's why, or else you'll have to use a nine-axis
Okay.
machine, nine-axis machine. So that is again more expensive. Per hour, it will be like 800, 900 rupees for using that. So it's like unnecessary waste of money, time, and energy. So that's why
Okay.
you should straight away say no. These sites I'm not going to do.
Got
Only these sites you.
9-axis machine.
Yeah. What happened?
What was it called? 9-axis?
See, we
No,
have.
I was asking about the machine.
Yeah, see, three axis is what in x direction will go, y direction will go, and z direction will go. Okay, so three axis is like more like
Mm-hmm.
VMCs. VMC is what vertical milling machine. So that's like see, five axis machines. What happens is the base is there, right, where the object is placed, product is placed. Even that will move. So like that, these axis of rotation, freedom of axis, or all those things is also considered. Because if it is nine axis, this bottom thing is also clamped, right? That will also move. It'll tilt to 45 degrees, then you
Mm-hmm.
can machine it. So it's more advanced, very very advanced type of machines. Okay,
Okay.
very very advanced type.
Mm-hmm.
So in aerospace industry, they use that. What else are going to do?
Assembly.
Save us. Save.
Assembly.
Yeah, yeah, assembly. First, I'll save this. So first example I'm doing. CAD, some assemblies here. See some assembly we had done here already. Let's do this. Do this. Put it here. New part one. So this is 50 die, right? So I'll open new part. Okay. I'll select this sketch. It's so hot. So this is 50 dia. So if it's 50 dia, what value should you give here? There it was 50. So how much should we give here?
For the assembly, you mean?
Yeah, 55.
50 would actually fit, right?
See, every time you have to give some tolerance. 49.5 or 49.9, like this you have to give. 1 clearance at least you should give. 49.8, like
1
this you should
mm.
give. Yeah, something like this you should
How
give.
much is the acceptable one? Like
See,
usually used.
usually I give point 0.1. or else I'll give
Okay.
1 mm, not point 0.1, 1 mm you should give. But since this is like, see, there's a standard chart. So from 0 to 30, it is point 0.1. To 100 to 200, it is 1 mm. 300 to 400 is tolerances for 4 mm, 3 mm, like that. We have a clearance chart, standard clearance chart. So in that we have
Okay.
to do it. So this is very minute clearance. So this will cost more also. So like that you have to do. But we have to
Okay.
make it fit inside. So
Mm-hmm.
we have to just pad it. Yes, okay. Okay. So we will save. Save here only. Okay. Now straight away going to the assembly workbench. Where is that? Go to Windows. In Windows, all those things will be open. So go to Product. So now we are going to do our top-down assembly. In this, what we are going to do is first see how to start, how to put something inside. No idea, right? So for that reason, here we have the C. We have component, we have component parts. So in this, in these two things, right, existing parts. In this, we can put existing component with positioning, existing component. These are two options that you have to use for top-down assembly. So existing component with positioning is when you're bringing some part from outside, right? So that part will
Mm-hmm.
have positioning. Okay, this here you can orient it and everything. Here is just directly just putting it. So after selecting this, nothing happens. So you have to select this product. After selecting this,
Mm-hmm.
see this is in red.
Mm-hmm.
Select the product. You'll get the dialog box. So in this dialog
Mm-hmm.
box, go down, select this, click OK, open. One sec. So you'll get the part exactly in the center. Okay, just like the main body or something. If you're putting, you can just put it like this. Okay,
Mm-hmm.
I'll just remove this. Next one is with positioning. So just select the product. Same thing you'll get. Just select this. Click OK. So you'll get a dialog box here. So you can see exactly how. See, this is center. So where should I place it? When you're doing assembly now, so that time it comes very
Mm-hmm.
handy. And here you can fix this component. So this is a base. Whatever is a body, the main body, what you have to do is you have to fix the component first. Fix means it should move from the
Mm-hmm.
position. Okay.
Mm-hmm.
So once that is fixed, you can click OK. See, I like that directly you can apply the constraints. So now I'll delete this. So what you have to do is, see, you can use multiple. Here, multiple products you can put here. You can select this and select this, and you can put both. See, both these things you can put. So this thing, first fixed component, and this. Once this is done, click OK. There you go. This also come. Leave it. Both is fixed, huh? What was it? Take this, take this, select both, click OK. So both you can put it like this. Right click. Something is wrong. Okay, leave it. So here basically we have many commands. First one is to move. So once putting it in the screen is done, next is what? Here we have the move commands. Then we have the constraints. These are the different constraints that you have, and these are the move
Mm-hmm.
commands. The first one is our manipulation. So in manipulation we get this option to move the components in whichever direction you want. So first one is X direction. So see the compass, this is x direction. In x direction, we can move it. Okay. Then we have y direction. Again, see the compass, this is y direction. So in y direction, we can move it. See the compass, this is z direction, we can move it in z direction. Here we have this arrow. This is our independent direction. So if you have any inclined line or something, you can just move this thing in that direction. Any edge you select and it will move in that direction. Okay, understood?
Mm-hmm. Yeah.
Then is the planes, datum plane. See x, y. X and y is this. So in this area, it'll move in this direction. See, x and y direction, it'll move, or x y plane. Then yz plane, y and z. Yz means this yz plane. This plane, it's going to move completely. Then is what? X z, x and z. Again in this plane. This plane is there, right? Wherever you place it, it'll be exactly on this plane. This will be exactly on this plane. Exactly on this plane. Okay, by seeing visually it will look somewhere else, but it's exactly on this plane.
Mm-hmm.
Okay, then we can select any plane if you want. Any other data plane if you have created with respect to that you can move. Next is rotating. Rotating with respect to x-axis. So this is x-axis. So you can rotate it with respect to x-axis. See this is x-axis. You can rotate it with respect to x-axis. Then y-axis. We can rotate it with respect to y-axis. Okay, and z-axis we can rotate it with respect to z-axis. And next is independent. Independent means with respect to whatever line or angle you want, we can rotate. So if you want this, I can rotate it with respect to this line. Okay, understood? So that's the advantage.
Yeah. Mm-hmm.
So first we'll just move this thing here, whichever direction you want, just move this thing outside. See, this is not fixed, so it's moving. Okay, good. So now once that is done, first we will do is, see here only we have the fixed constraint. So fix this thing in this position so that it doesn't move. Next is what? Next to that we have something called snap. So snap basically is like constraints, but it's not constraints. Like in constraints, we can move it, you can position it, we can do all those things. Okay, but the constraints is not applied. Okay, you can see, we can just rotate it. See, we can rotate the product. We can just take this and we can take the center, put it here. See, it's like constraints. We can rotate it if you want. We can do anything with that. Okay, using this, it's again positioning, moving the part from here to there like this. See, you can rotate it if you want, like this you can assemble it.
Mm-hmm.
Okay, but always remember key, this is just an this positioning movement, see, move command, it's just a move command, nothing else. Okay, once this is done, uh, I'll just hold control, I'll drag this thing. Okay, so I'm coming, so leave it. So what I'll do is I'll just right click, copy, I'll just put it here, I'll paste it here. Okay, see, part 2 is copied. I'll just move this in x direction. Okay, I'll copy this also. Yeah, so you saw this, I applied snap over here. Okay, for this part. So I think so, yeah. So yeah, correct. So now click OK. Now we are going to apply serious constraint for this. So here we can see coincident constraint. So in assembly workbench, 90% 90% of the things assembly like constraints you can use this constraint itself. Okay, this constraint
Mm-hmm.
only you can use. Right click, copy and paste here. Okay, maybe one more time. So most of the 90% things you can use this constraint only. So you can just select this,
Mm-hmm.
close, select the center axis, select the center axis for the circle. Okay, done. Select this and select this. See again. Wait, I'll just position this one. Which axis? Z axis. See, I'll just move it here. See, in using constraints, I made the center axis coincident. Again, using the
Mm-hmm.
don't prompt again. Close. Again, using the coincident, I'm going to make this faces coincident. See, like this. So most of the things you
Mhm.
can use the same tool for most of the applications. So see, you can see these two are constrained. Okay, now what I'm going to do is I'm going to use a move command. I'm going to pull this thing out. I'm going to pull this thing also out. These two things I pulled out. One I used snap, one I used constraint. Okay, so the one in which I use constraint, this circles are seen. In this snap, nothing is seen. Okay, now what I'll do is I'll update. When I update it, the one which is constrained goes and sits in its place, and the one which I use
Mhm.
snap is just lying down there. Okay, so that is why
Mhm.
we should always remember to use the constraints, not just the snap tool. Snap tool you can use for your advantage, but always remember to use the constraints first. Okay, click OK like this.
Okay.
Now even if you drag both out, yeah, it'll come back to its position automatically. Okay, see now if I click OK, update, both will sit back in its place. So the assembly is done. Okay, understood?
Mhm.
This is how you do the assembly. Then here we have contact constraints. The contact constraint again, it's the same thing. See what we did with coincident, na? Same thing only, that is that what happens. See, face to face constraint it is. See this face, see this face to this face. That is your contact constraint. But that is again double work because the phase which it's going to select might be ulta. See now what I've happened is it selected the wrong phase. It's unnecessary waste of time. So that's why I prefer this constraint most of the time. By x-axis, yeah, like this. Here only now. Yeah. So select this phase, select this. So it's going ulta now. So it's unnecessary waste of time. Better than that is using this coincident only. Automatically infected. Then is this distance, offset distance. So for that, I'll delete this. I will delete what is this constraint. I'll delete this on the center. Okay, that's okay. Now I'll just move this thing little up. Click OK. Now sometimes we'll have to position the part at certain distance. Okay, certain distance. Then we have this offset. So we can select this face and we can select this face and we can specify okay, how much distance you want. Maybe 20 or 30 mm. You just give the distance here. This is negative directions will be negative. Click OK. So that position you can 20 mm distance you can give or any distance you can give using this offset constraint. Okay, this is the offset constraint using that. Then angular. If you want to give any angle, again similar to this, we can select any part, any face, and we can give the angle between those two. It was fully defined. So here we can specify the angle. So two parts you select, two planes, this face and this face. Here it's constraint we can use, but two faces you select in which you can apply the angle between them, and here you specify the angle. Okay, and you'll get it.
Mhm.
Then this is a fixed constraint which we used. Okay, and here we have the pattern. Okay, user reuse pattern. So now basically you saw we used normal circles, right? So that's why we're
Mhm.
getting this. So now one more thing I'll show you, important thing. So now see, these are the parts that we did, right? So part one
Mhm.
is the base. So if I click on plus, if I go to specification tree, you can see I can see the part body. See, I
Mhm.
can see the pad, I can see the chamfer. So what I can do is I can just double click on this. If I double click, what is happening is I'm going to the part
Pod
design
body.
workbench. Yeah, part design workbench. See, part design. I just double
Mhm.
clicked. So now what I'll do is I'll just
Yeah.
go here. I'll double click on the sketch. I can do the editing part also. Understood? So I'll delete this.
Mhm.
This is called bottom up approach. So all the sketches you can do it by yourself in this position. Okay. Now once that is done, what I'll do is I'll update it. I'll select this plane. I'll sketch. I'll add a pocket at a distance of 50. Enter. Then what I'll use is pocket. Click OK. Throw out now. Throw out. Then I'll use a pattern, because to use that reuse pattern command in assembly workbench, make you should
Mm-hmm.
100% use pattern command here. Only then you'll get that thing.
Oh.
So this thing, um, what distance? What distance here you put? Okay. Now second direction also you take this direction. Add one more. Okay. Click OK. So this is done. Now to exit this pad thing, go to double click on product. If you double click here, you'll get this. So you can see these constraints all here and there. Okay. So what I'll do is I have to constrain this again. So just move this up, up, up. And one more thing before putting this thing in assembly, just before saving the file, just hide these things. Hide the datum planes. Because see, it's so confusing here.
Mm-hmm.
So just hide it in there only when before saving it. So we don't need those things. So here you can see 20 mm. Just delete everything because these will be over constrained. Okay, that is surface. That's okay. So now we'll just take constraints. Sorry, center axis, center of this, center axis, center of this, center axis, center of this. Then select this to this. Okay, this to this. Okay, this to this. Okay. Okay. So now I'll just
Mm-hmm.
what we are going to do something. This thing I'll just hide. Control Z. This thing. So wait, we don't need to do so many things. So I'll basically delete these two things. So much time we used here, right? So what I can do is straight away use this command. So pattern, which is our pattern. So you have to open this. So this will be closed like this. You have to open. You have to select this rectangular pattern. So all the pattern, everything is shown. So component to initiate, our this component will initiate. Just within how many seconds? 0.1 seconds. I could do this. See, all those things is done. So like this, I could save my time. All the constraints is also reapplied. So that's why
Mm-hmm.
we always make sure to use constraints like patterns in your model. As I told you before, this fillets, all those
Mm-hmm.
things don't use in Sketch. Make sure you use it there. So this is how your assemblies. This is only so much is there in your assembly workbench. Then here we have this trim command, this whole all those things. This you can directly, as I told you here, open this, go to your part design, and you can do it. No problem. Understood? Then yeah. What else is there in
Yeah.
this? Yeah. So now we'll do one assembly for one parts. So I'll just show you this. You take this as an assignment. Where is this assembly? Yeah. Take screenshots and try to complete it.
Can you zoom in?
It's okay. Don't worry about this. I'll give you more photos. Done.
Yeah, done.
Okay. Done,
Yeah.
Prabha?
Uh-huh.
Next, this.
I can't really see what's there. The
Don't worry, I'll just give you more focus. You just take this.
mm, yeah, yeah.
Have patience. You have very less patience.
Mhm.
You're always in a hurry. So this you take.
Yep.
Srivadan, done?
Yeah, done.
Okay. This you take. So this is called BOM, Bill of Material. So how many parts is there in your model? So all those things is documented here. Okay, so the manufacturing team, they can see, okay, how many numbers are there, four numbers are there. So they'll accordingly they'll manufacture it, accordingly they'll assemble it. So all those things is very important. Bill of materials, one of the most important things in mechanical design engineering. So in not just this quantity, they'll give the material type. If you're procuring the material, they'll give you the make. Like if you're taking QDCs, there'll be like different companies. You'll have Hamlet, you'll have Stubbly, you'll have this Parker, have multiple companies. So those companies make will be shown here. What material they are using will be shown. So all those things will be, and the part number. If you're procuring it, the part number of the product will also be shown here. Understood?
Mm-hmm.
So that is called bill of material. And item number you can see, not that item number. This is this item number here. See, 1, 2, 3, 4, 5, 6, 7. So it's like showing which part is where. That is this one. Okay, so you have to see
Mm-hmm.
this. So number one is body is here. Then two, thrust bearing. Number two, thrust bearing. Number two, thrust bearing. So like this you have to see what part comes where. And this you take screenshot. This was the one which you had a problem where it was not seen properly. You can take screenshot of this. Done.
Done.
Yeah, done.
This also you take. This is this one.
I'm done.
Yep.
Take this.
Done.
Yeah.
Yeah, very so much. So seeing all these things, study it properly, then you do it. Because I'll show you why. See here in this part, they have given the outer diameter 6, all thickness, everything they have given. This is stock support ruler, right? They given, they are not, see if you take the stock support ruler, what is this? Yeah, if you take the stock support ruler, number 4. See number 4, this here is stock support ruler, but this rod is passing through it, right? This rod is going inside
Mm-hmm.
this. So if you see this number 3, this rod is number 3. So number 3 is support adjusting screw. So the support adjusting screw is going through the stock support roller. So but in this, if you see stock support roller, there is no inside diameter they are given, right? So support adjusting
Mm-hmm.
screw is here. So this thing is going inside this. So what you have to do is diameter 3 you have to make inside. Okay, then only this thing will go inside. So you have to this is how people like the manufacturing team, if some dimensions missed out, they do this. They check it like this. So this thing will go inside. Once they have the clarity ki this is going inside this, they'll automatically take this diameter. Okay, like this they have to do. Understood? So study this and accordingly do that. Understood? Now we'll do this
Mm-hmm.
assembly part. So we'll just close this, not required. Nope. We'll close this also, not required. Nope. So we'll just open assembly, mechanical design, assembly design. So we'll just click existing parts, select this. We'll go to assembly. All the parts we'll select. We'll put it here. Okay. This is done, already done. So we'll just take our move command. We'll just put it here and there. So this thing is here. This thing will go up. This thing somewhere here. This thing will come below that. This thing. So now this y-axis, this will put here. Okay. So these are the parts. So now I'll just click OK. So now our coincident, with coincident only I can do everything. I'll select this center axis of this, that is done. Then this part, same thing I'll do. This thing, center axis of this to center axis of that is also done. Then center axis of this to center axis of this circle inside. Wherever circle is there, you'll get a axis. So it's much more convenient for us to constrain it. So center axis is also exactly in the center. Okay, that's done. Now we can take coincident again. See, this circle is there, center axis you take. Here also one circle is there. Wherever circle is there, you can give the center axis. Okay, that is done. Now select the surface. Again, I can use this coincident constraint. I can select the surface. I can select this surface. Okay, done. Click
Mm-hmm.
OK. Now I can select this surface. I can select this surface to that of this surface. So that's constraint. Click OK. Now I'll just push this thing inside some distance. So I'll just select. Wait, I'll just better this. I'll give coincident to this. Where is this surface to this surface. I'll give. I click OK. So you can see this came inside. So
Mm-hmm.
what I did is I gave coincident to this surface again, that rod. So that is done. Now we have this chotu thing. So this also I can give coincident constraint. This one I can select center of this. I'll select. So it's come till here. Now what coincident I can apply because this is circular in shape. So what I can do is I can give distance from this flat surface to the center axis you give. Here I'll give 2 mm. Yeah, okay. So this is done. Now similar to what we discussed earlier, this part will just go open, open, open part. Doesn't see circular pattern is there. So no need to break your head. Just within few seconds you can complete it. You can just select
Mm-hmm.
the circular pattern. So all the circular patterns are selected. Then which component you want to pattern that you click. That's it. Rest the
Mm-hmm.
computer will do. So click OK. So work is done. See your assembly is done. Within how much time? Within few seconds your assembly is done.
Mm-hmm.
Understood?
Yeah.
Srivardan, any doubts in this?
Should we also constrain the roller top of thing on the top?
I mean, it's already constrained.
Uh,
See, it's already
we
constrained.
constrain it to the axis, but not to the side. I think.
Inside,
I
what is
think
the?
it should still be.
It should. We can.
Yeah, we only constrain it to the axis, so it can still move on the axis, right?
Wait, let's check. Like this, let's see. Move in the axis. Yeah, that is there. If you do this, just check it like this. Just give use update command. Update. Something wrong with this. Again, I think there's some system error. Okay, that's okay. You can just give the dimension to fix it. So you can give this surface to this surface. You can give 2 mm. We give the right point 2 something. We give. Click OK. but that's also too much for it. Point 0.1, because the dimensions for this is very small. Point 0.1 also I think it's very big.
I think it should be a contact constraint.
It's not contact. It should have some free movement. Zero.
Yeah.
Yeah, yeah. We can give contact constraint. Yeah. Again, coincident we can give it. Okay, now it's fixed. Can give dimension, or we can just give coincident to surface to surface. Anything else? Any other doubts? Here we have this explode command. Using this explode command, all levels you give, one product you give, fixed product you give the center thing, apply you give. So you can see this is the assembly. Okay, this is your assembly. Okay,
Mm-hmm.
everything, whatever parts you used, everything you can see from this. I can just update this automatically. It'll come back to its original positions. That is here it is there, explode command. Then what else you have? Yeah, so much. Anything else? Yeah. So we'll save this. It's already saved. For drafting, it will come handy. Okay. Any doubts in this?
Nope.
Yeah.
Okay. So only so much is done in assembly. Nothing to break head. So concentrate on part modeling. Do one more example for that. Here I'll give you this hook also. Try to do this. It's not that complicated. It may seem complicated. It's multi-section solid again. One circle here. This one profile you draw here. And this one circle you draw here. And instead of spine, you have to use guide curves. Well, you can use spine also, no big deal. Use spine only. Okay, understood. You can use
Okay.
guide curve or you can use spine. Both it's okay, no big deal. So you can just draw the circle, draw this profile, and this circle you draw. You need to draw this. We'll get the hook. Okay, take screenshot of this. Look for multi-section solid. And don't do it in a hurry. Take your time. आराम से. Okay,
Okay.
that's specific. That's specific to Prabha.
Yep.
I don't understand the hatched portion in the drawing.
This thing actually they're showing the cut section. Wherever hatch is there, that is
Okay.
a cut section. They're showing what is
Okay.
inside so that we can do it. So this is how the hook is going to look in this shape that they can't show you, right? So they have put it here. So
Okay.
if you draw this profile, when multi-section solid is there, it will take the shape of the hook. Okay?
Oh, so at that point, it's not a circular profile.
No, it's not circular. It's not at all
Okay.
circular. It is in this shape. So you have to select this datum plane. You have to draw this profile. You have to select this datum plane, draw a circle. You have to create a datum plane here. After creating this plane at this location, normal to curve, you have to create a datum plane here at this certain angle. Automatically will come. And here you just have to see 150 on distance. You create this datum plane and normal to curve you take, so you'll get this angle and this circle you draw. So 1 2 3 profiles you have. From here you'll get a hook. Understood?
Yeah.
You don't have to. Yeah, you have enough time, right? Yeah, next week. So take your time, aram se do it. And these parts, these child parts, okay, if you have any doubts, you can ask me for that assembly thing which I had showed you. This is This is like normal revolve. That's okay. And this only difficulty is this one, understanding this. That's why I given you this, because it'll take some time for you guys to process it. Okay. So
Mm-hmm.
basically, one shortcut is just revolve it. Okay, work is done. Within 2 minutes, you can do this. 2 to 3,
Mm-hmm.
4, 5, 10, 10, 15 minutes, you can complete this. So you just create this profile, order dimensions there, just create this, give a revolve. So 90% of your work is done. Okay, then you have to create this you create one pattern, work is done. Then here this rod is there, center data plane you select, or you create a data plane outside, create this. Okay, this thing, this circular extrude, and here on top also little extrude is there, multi section, this thing, multi pad you can use for this. Once this is done, again mirror command, this is mirrored over here, work is done. And here something is there. This is again you have to use some data plane at some distance, whatever distance is specified. That's as you are 12 they are given. At that point you create a data plane, just extrude it, and here give a pocket. Your work is done. That's it. This whole thing is done. Then this thing is also the thing. Just create this profile, extrude it to a distance of something here they are given. Extrude a distance of 4 mm. Okay, this part is complete. Only the side flange is left out, that you can randomly create anything. Random flange you create just for seeing sake. Thickness 1 mm you give, this randomly you create. And then in circle, there's a circle in center. Why circle in center? Because this has an oil hole, so there's something going to rotate. And one more thing is here, this thing where it's going to sit. See, oil hole is here, this rod is going to sit. Three is that support stock roller, and this thing is number five. So number five is that support roller bracket, and number for a support roller. So this thing's mouth, this 2 mm, is going to sit inside this. So they have not given the diameter of this hole, so the diameter you have to consider 2 mm. So that 2 mm will go sit inside, like we did the assembly right now, right? So this 2 mm
Mm-hmm.
will go sit here. This is 2 mm dia. So it's sit here. So this is 2 mm. That's all. Nothing else is on that. What else? This is around say this revolver. Work done. And these holes, see, this hole is like from 1, 2, 3, 4. They have not shown it here, but since we did the assembly, we know one. This thing is going inside two. This is going inside three. So obviously one more will be there in the back side. So four holes. Four holes, and as we discussed, this thing will go inside this. So there are one more circle inside. That's all right. And this thing is again just revolve. Just create one side, give revolve, or else you can just draw circle, pad. Anyway, you can do it. This is again
Mm-hmm.
pad only, nothing else is there. This is again, see, you can just create 120-degree line, give angle, just draw this. See here, they're not given the distance. But wherever distance is not given, just assume it. You don't have to break your head. It's just an example. Okay, this is an
Shall
example.
we revolve too?
Huh?
Shall we revolve this too?
Yeah, you just have to revolve it. So
Yeah.
just create this and just revolve it. You can just create half of it and revolve and mirror, or else you
Yeah.
can create this one entire half and just revolve it. Anything you can do.
Mm-hmm.
Okay. So
Okay.
just take your time. If you just observe it, see it, take your time and see it. It's nothing. It's easy. Okay. You'll be able to do it within 45, 50 minutes max. And if you want some leisure, you can take some more time. 2 hours you can take around. So you can do. Don't take so
Mm-hmm.
much time. Maximum the
Mm-hmm.
actual time will require for you to do entire thing is 30 minutes. Actual time. You can do it around. So this
Mm-hmm.
is done, right? So try to complete this also. As I told you, just this is normal part. From here you have to start your intersection solve. Understood? Understood?
Mm-hmm. Okay.
So try it out.
Okay.
Any doubts? Just WhatsApp me. Okay.
Okay.
So then let's wind up for today.
Mm-hmm.
Okay.
Have a good day.
What happened?
Have a good day.
Yeah, same to you. Yeah, have a good night's sleep.
Yeah.
Okay, chalo then. Yeah, see ya. See ya.
Right.
Bye. Just